First, I'm going to share the materials with you, and I'll share my screen and show you what you can do with these. The materials come from this. That's the link to this meeting. Copy paste doesn't work sometimes. Boom. So check the chat. Look at that GitHub link. I will put the page on my screen. If you are not familiar with GitHub, that's really fine. You don't need to be, and you don't need to have Git installed either. But if you are familiar with those things, then what I would say is just clone this repo. We are going to be looking at just the classes section today, just the stuff in this folder here. So if you want to clone the whole repo, you can do that from the command line if you know what I'm talking about. If you don't, the easiest thing to do is click this button, this code button right here. And I'll show you what it looks like when I'm out of annotation mode. Click that button and then just download this as a zip file, unpack the zip file, and you'll be left with a bunch of folders and files. And then I would open that up in your favorite code editing software. I'm going to be using VS Code. If you don't have a text editor that you already like, VS Code is a great one to download. You can just Google Visual Code or Visual Studio Code rather, but Visual Code works. Go here, download it, that's fine. And if you want to do this the same way that Ian did the last class, just copy and paste Python code into something like REPL, then you can click on the classes and objects folder, and then each of these Python files will be a, oh, I don't see them change there. Each of these files is a Python file, and then the exercise that I have for you is a markdown file. You can read that in here, but we'll get there when we get there, okay? So clone these materials or just click on these one at a time as I go through them. So you could, for example, click on this first Python file, copy this code into REPL. Then once you have those materials, you'll open them up in your favorite editor. I'll just go to Visual Studio Code here. And then you can see I've opened this entire folder of all those classes here. We're talking about Python classes today. That's in this 6th folder. And this first file, O1 classes and objects, is the first thing to talk about. So basically classes, and this is not a concept that's unique to Python. Almost every major programming language has a classes implementation. They can vary a little bit from programming language to programming language, but they are a way to bundle together pieces of data and functions that operate on that data. And if you've used any of the basic built-in objects in Python or data types in Python, you've actually already been working with classes and objects. So I'm going to put a breakpoint on this first line here, x equals a list. Stop me if you have not used a list in Python before. If this line of code is unfamiliar to you, please let me know. Cool. So I'm running this in debug mode. You'll see I'm paused on the execution of this line of code here now. And what I'm going to do is create a variable called x. I'm going to assign it to be an empty list. And then in these next lines in this print statement, you can see two things that are important about the way Python handles classes. First is this dunder class property. So X is a complex data type. All complex data types are objects. All objects are the instance of a class. So a class is like a template for a type of data, and an object is an instance of that type of data. X, the class of X, as you'll see when I print this, is going to be the list type, which is also what prints out when we ask Python using the built-in type function, hey, what's the type of X? And then finally, you'll see when I ask the question, hey, is the type of X equal to the class? This is going to be true. Okay. So you step over. The special dunder property of class is this thing's the list class. The result of the type function right here is that this thing is the list class. And those two things are in fact the same. The list high-level function that Python provides you, the top-level built-in function, is the same as X's class property, okay? So this is just a way, classes and objects in Python are a way to define different data types. Let me pause here. Thoughts, questions, comments, concerns. Go ahead, Ian.
So I noticed that the word list here doesn't have any quotations around it. Does that mean that it's like a built-in variable of some type?
Yeah, this here
Hmm.
list. Yes, so this is a built-in, it's part of the quote built-in namespace in Python. It's always available. It's a top level function. And in this case, it is both simultaneously the type of thing that is a list, and you can actually also use this if you want to create a list. So I could say, for example, y equals list, and if I restart this code from the start, then what we'll see is that x gets an empty list, just as we did before. And if I step over this y line of code, you can see y also gets an empty list. So this is called a constructor. That's a name we'll use again later, a constructor function. This is a function that creates an object. This object happens to have the type list. Is that what you're asking?
Yeah, exactly. Perfect. Thank you.
Yeah. One of the most useful things that classes have is the ability to contain data inside of themselves. So for lists, for example, right? Right now, x and y are both empty lists. If we step over this line of code, x.append 1, then a piece of data, that string, the string 1, gets added to that list. And this demonstrates the two key features that objects have that we like as programmers. The first is called behavior. This method, this is a fancy name for a function. We said x.append. That is a method that belongs to the list class that gives this data type behavior, specifically the ability to add items to our list. Okay. The second key feature that objects have is state. We used to have an X with nothing inside it. It was in a state of being an empty list. Now it's in the state of being a list with the string 1 in it. Okay. So classes create objects. Objects have behavior. They have methods, functions that you can call that might change the state of that object. And we use this design pattern in tons and tons and tons of ways. One easy way to conceptualize this if you play video games is you might have an object for the character class. And when you take damage, you change the state of your character because your HP has decreased or something like that. Another useful way to think about these is like you might have user objects if you're building a website, and your user has state like signed up for the newsletter list. They have state like their order history is a piece of their state. And every time they check out on your website, methods will add behavior to your user object that will update your state by checking out, paying, et cetera, et cetera. Okay. So these three lines of code, we're just adding three things to that list. X now has 1, 2, and 3.0 in it. We have used the append behavior, the append method, 3 times to change the internal state of our list. Okay. And this is just to show you that you've already been using these things, classes and objects. What we'll do next is create a custom class so you can see how these data types are built behind the scenes. But almost everything in Python is ultimately an object. It's an instance of a class, and the list is no exception to that. Also, strings and integers are not exceptions to that either. We'll actually loop down here and print out some property names of those data types, okay? But let's pause here again. I've said a lot about classes and objects. This is often a topic that's confusing for people who are first encountering it. So I would anticipate some of you might be confused and have a question. Yes, Victor, go ahead, please.
Yeah, so like I said earlier, I have mostly a JavaScript background. So I'm seeing that a list is a lot like an array in
That's right.
JavaScript. Can you just explain some of the differences between the two?
So there are a lot of behind the scenes implementation differences that really aren't very important. They're just design decisions that the maintainers of JavaScript interpreters, Python interpreters have made. Conceptually, a list and array are almost identical. They both contain an ordered set of data. In JavaScript and Python, they can both contain data of various types. So you can see here with X, we've got a string, an integer, and a float. And JavaScript is the same way. You can put any different kind of data in your list. You can sort them. You can remove items from the middle. At a conceptual level, they're totally identical. The few different weird implementation differences has to do with the way they handle kind of empty indexes. So in JavaScript, you can do something like, let X equal a new array, and then you can say X sub 1000 equals 6. And in JavaScript, it's perfectly happy to let you do this. In Python, you'll get an issue. It'll say, hey, this is out of bounds. You can't insert something at index 100 because there's nothing in here. There's no index 100. This array doesn't automatically resize itself by inserting at the 100. And that has to do with the way JavaScript inherits the array class in JavaScript inherits from the object type in JavaScript. And so this bracket notation means something slightly different.
Thank you.
Yeah, you're welcome. What else? Cool. Then let's do two more quick things with these built-in data types, and then we'll look at a class definition. Okay. So here I'm just printing out X. Here I'm showing you something that is very unique to Python, this dir function. This is a function that's designed to help you, the programmer, understand what is in any particular data type, what properties it might have, what methods it might have. So if I print the result of this dir function being called on X, then you can see all this crap gets printed out. These are the properties of the list class. And all of these things that start with dunder, we will look at some of these in a minute, dunder for double underscore. You'll also hear these referred to as, quote, magic methods in Python. These are ways that Python knows how to control specific behavior. So for example, this double underscore add function is called behind the scenes when this data type is used with the plus operator. So for lists, for example, if I say X plus Y equals, or sorry, I should say Z equals X plus Y, then the list operator or the list function, list data type, the list class, has this add function implemented, and it is called behind the scenes when you add two lists together using the plus operator. So you can overwrite these methods. GE is for greater than or equal to. That's this operator, greater than or equal to. Len is what happens when you call the length function on something, which gives you the length of the list in this case. So these magic methods or dunder methods are ways to control the behavior of your class using pieces of syntax that are, already built into Python. Okay. And then you can see the append function that we used, clear, copy, count, extend, index, insert, pop, remove, and reverse. These are all methods of the list class. So this dir function is just a handy way to get information out of your object. What properties and methods are available on this data type? And by the way, in the debugger, you can actually see that same information by looking at the special variables. You can see all the same ones there. And the function variables, you can once again see the same ones. Append, clear, copy, count, extend. Cool. So this is nice to know about when you have a data type and you're not familiar with it. You can call the dir function on it, introspect it, get some information out of it. And then here, we're doing a loop. This function here, vars, is very similar to dir, but it's designed, dir is designed for humans. It's a way for you to learn about what's in your data type. Vars is designed to be programmatically. So here, I'm looping over all of the properties of the list class. Okay. And this thing here, vars, gives you back a dictionary. That's why I'm using the dot items method here. And what we'll see here is, looking at what gets printed out, we're going to print out for each of these magic methods and regular methods, we're going to print out the name of that, what type of value it is, and what its type is. And we'll step through a couple just to see them. So the hash is a none type. Hash doesn't exist, but it's named. It just doesn't have a value. Get attribute is a special slot wrapper type, class slot wrapper and class wrapper descriptor. And if you loop through enough of these, you'll get to see that some of them are these slot wrappers, some of them are functions. I'll just click play, and you can see reverse is a method. All of these final ones are methods, which are special types of functions that exist within classes. Size of was a method, reversed was a method, IAD was a wrapper. So these are just two ways to explore when you have an object in your hand. Explore what that object contains. Okay, so little micro exercise here. What I'm challenging you to do is using dir function or this vars function, try calling that on a different data type. I've shown you what happens when you call it on a list. Try calling it on an integer or a string, and then report back to me what happened. I'm going to put 2 minutes on a timer off screen for you to attempt this exercise. Any questions about what I'm challenging you to do here? Then have at it.
Hey Tyler, I'm using VS Code for this exercise as well.
Great.
This is my first time using Python on VS Code. I just wanted to ask, are there any extensions that you recommend I download?
Yes. I would download the Python extension, the Microsoft official one. That's the only one that I use all the time.
Okay, thank you.
Cheers. Okay, beep, 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 beep. My timer's going off. How did that go? Anything interesting when you DIR'd on, for example, the integer 1? What do you have to report to me, friends?
There's a lot more happening behind the scenes than I would have expected.
Yeah, a ton.
A lot more functionality available to me, and it's nice to see it all in one place.
Okay, sick. Jeremy, Victor, anything? No one's upset that I'm getting something like the argument must be an iterable if specified class string. But it works if I go str. Oh no, it doesn't like that. Where is this bug? Oh, that's from earlier. Oh, duh. Come on. Someone knows why this isn't printing anything on the screen, don't you?
You didn't have a print statement.
Yeah, absolutely.
Thought you were inside of a REPL.
Thank you. I did. So you can see strings have bunches of stuff going on. We could put the number 1 back in here. We can see even integers have some stuff going on. Oh, not much though. Just, oh, I didn't dir it again. There we go. 2 bytes, real, numerator, denominator. Conjugate. Wow, good for them. Okay, so every data type in Python is a complex data type. Whether you thought it was a primitive like a number, an integer, or not, you really can't get away from objects in Python. They follow you. Okay, let's take a look at a sample class next. This is just the second file. If you're following along, we're in O2 making classes now, or if you're on the website, it's still the same name on GitHub. Okay, so in Python, to make a new class, you use the class keyword. And just like for loops or function definitions, the class keyword ends with a colon, meaning it creates its own block. Okay. And then you also give your class a name, just like you would give a function a name. But you'll see there's no parentheses here. So it's different from a function definition in that there's no way to accept parameters at the class definition level. We'll see you can accept parameters in just a moment in the constructor function, the init function here. Okay, and by convention, it's not required, but it is standard to do, and almost everyone does this. the first letter of your class should be a capital letter. Whatever you're naming it, it should start with a capital letter. The normal thing to do for classes is capital camel case. So if you had a second word, you'd capitalize. Even though everywhere else in Python, we use snake case with underbars to join words together. In class definitions only, we tend to use capital camel case. Fun facts with convention land, okay? So you create a class like this. This class is called user. You have a colon, then everything inside of there is indented that belongs to the class, okay? So this first type of function here, this first function is the init function. Dunder init, you can see this is a magic method. Basically, every class you create is going to have this magic method. It's the only one that is totally ubiquitous. I'll show you the use of some other ones in a minute. But this is the function that actually creates your objects, okay? So remember, I told you that classes were like a template for producing a particular data type. The user class defines what the user data type can do. And when we make individual users, those are objects. They're instances of the user class, okay? And this init function is the thing that defines, it initializes, that's what init stands for, our objects when we create them, okay? So in the case of a user, we're going to receive an email, a name, and an age. And then we're going to use this new, this is a special, it's not literally a special reserved keyword, but by convention, again, too many things in programming are done by convention. This is one of them. By convention, we use this self. The first parameter of any method is the self parameter. And that refers in this case to the object being created right now. Okay. So before I talk about these other methods, I'm just going to come down here, put a breakpoint, and demonstrate the use of this constructor function. So on line 29, we're going to say, make a new variable called user Tyler, and then I want it to be a new user object. So I use the name of my class, user, and I pass in all but the first parameter. Remember, this has 4 parameters: self, email, name, and age. And self will automatically be populated by Python when you invoke the constructor this way. Okay, so Teb at Teb's lab is going to be the email, Tyler Batillion is going to be the name, and 58 is going to be the age. By the way, I look pretty great for 58, if I don't say so myself. Okay, so I'm going to kick this off in debug mode. We're going to drop down to this line of code, and then when sorry, I got to move the zoom box, which is hiding my debug tools. When I step into this function, it's going to take me to here. Let's see it happen. Boom. Now I'm on line 14. You can see that the email, which I passed in, is teb at tebslab.com. Right now, the self object doesn't have a property called email, but it is about to be created. When I step over it, boom. I've added that property to the self object, which is going to be returned automatically back to where I called this function. Similarly, the name that I provided, Tyler Batillion, is going to get copied into self.name because I told it to. And my age, 58, is going to get copied in there as well. I've stepped over, the function ended, it died. So the thing that was returned from that class, from that init function, is now this user Tyler. Age 58, Teb at Teb's lab, Tyler Batillion. I've created an object. Okay. Let's pause here. What do you think about this concept, the constructor slash initialize function, the syntax of defining a class and that function, or this, actually instantiating an object, creating an instance of the class?
Yes, I have a question.
Great.
So, let's say you were for age to put a string instead of an integer. Would that return any type of error?
Ah, okay, let's try it out. What do you think? Just make a
Oh,
guess.
Well, I see you have it as a string
I
right
just
now.
changed that. It used to be the number 58, and then you asked my question, so I just wrapped it in quotes.
Um, it, I guess it would uh just be a string.
Yeah, you're exactly right. In Python, it doesn't care. It is very loosey-goosey with data types. So what we'll see when I do it this way is this all works, but now my user Tyler is age string 58. And if I try to do mathematics on that 58, if I have a method that's like get older, which actually I think I do, yeah, birthday. Now, when I try to call the birthday method, this will be a problem. Let's actually see that happening. Where do I call birthday? Not until all the way down here. And it looks like I only call Sarah's birthday. So let's just add a line right here. Let's say user Tyler dot birthday. I misspelled birthday. Okay, great. Now I'll restart it. And Victor, you'll see that we'll get an error now, but not when we create the user, but when we try to age the user up by having a birthday, I'll print, hey, Tyler Batillion got older, and then it'll say, uh-oh, you can't concatenate strings with integers. Okay, so this is a well-known weakness of Python. It is not what's known as a, quote, type-safe language, which is to say, Python will not enforce the type of this data. I can cause it to do that, and in certain cases, it would be a good idea. There are two things you can do. One is type annotations, type hints in Python, which are like, I can't remember the exact syntax, but you do something like an @ symbol here, and then you define what type you want each of those parameters to be. That's not enforced by the compiler, but you can do this, assert type age, and then say it's equal to whatever type you want it to be. Int, for example, maybe I only want my ages to be integers. I can do this, and then when I try and give it an age of 58, I'll get an assertion error. Or I could be even more robust and give my user a better error. I could say something like, if type of age is not an int, raise a new type error. Age must be an integer. And this is a way to make your Python functions and methods much more safe. Now, when I run the line of code this way, I get this nice meaningful error message. Hey, age must be an integer. Whoever called this code can go, oh, yeah, you're right. I screwed that up. I needed age to be 58, not quote 58. What do you think about that, Victor?
That's pretty cool.
Okay, cool. So that is how you make a class in Python. Let me restart this debugger, get back to where we were. I'll show you the printing of the dir and the vars on this object we just made. When I dir it, you can see there's still a bunch of stuff that's been basically handled for me, created behind the scenes without my intervention. All of these magic methods are automatically defined. Effectively, we're inheriting them from the base object class that always exists. But then you can also see the properties that we defined explicitly: age, birthday, email, generate report, and name. Okay, and vars works exactly the same way, except that we get this dictionary of the properties and we don't get the magic methods. So you can see my email is Tebeteb's my name is Tyler Batillion, and my age is 58. We're not getting any of the function methods nor any of the special methods when we use vars. Okay. So the other generally useful thing we want to do with classes is give them behavior. In init, we gave them some initial state, an email, an age, and a name in the case of our users. And now we're generating two pieces of behavior by giving these classes functions. When a class has a function, we call it a method. It's a bit of nomenclature that will not be used 100% consistently, but that's what it's supposed to be. If you have a function that's not in a class, you just call it a function. If you have a function that's in a class, you can call it a method. Okay, but people will call these functions also, and that's not exactly wrong. So we have two. The first one, generate report, only takes this special self object, right? Which means basically it takes no input. It only introspects on the data that is internal to this object. And in our case, when we generate the report, we're going to use this f string to say the person's name, followed by is, followed by their age, and their email address is, followed by their email address. And then we'll return that report back to whoever called this function. So this is a behavior that only reads the data in the class. It doesn't change anything about the state of the object. The second function, again, takes no additional input, the birthday function. It just introspects on the object in hand and says, that person got older. And then it plus equals 1 on their age. Okay. So two pretty straightforward functions. Any questions about these two functions or what they do or how we've defined them? Cool. Then let's look at using them. We're paused on this line of code down here. So the user Tyler object that we created, me, is going to call this generate report. And by the way, one thing to note in Python, with the exception of when we call this, the init function, the way you can know what the self object is going to be is it's whatever's to the left of this dot. Okay, so when I say user Tyler dot generate report, then whatever object user Tyler is, when this generate report function gets called, that's what self is going to be. Okay, so when I call generate report here, if I step in, you can see that self is me, Tyler Batillion, Teb at Teb's Lab, age 58. It's going to print these facts. Well, it's not going to print yet. It's going to generate a variable called report and put these facts into that report. So now you can see the report here. Tyler Batillion is 58 years old and their email address is teb at tebslab.com. What a detailed report. Thank you. I return that report and you can see since I just stepped over, the print statement finished and it printed that same report back to the screen. Okay. I can create another user. This is Sarah Middleton, whose email address is sarah at fakeemail.com. But it's pretty clever because you don't do that E twice. It's fake email. 1E. Haha. Okay, sorry. And it works just the same. So user Sarah now is going to have those same properties that we defined for her. She's age 32. Her name's Sarah Middleton. And we can check that these two users have the same type. This will be true. The type of user Tyler and the type of user Sarah are both our custom user class that we created. So this will print true. This line of code is demonstrating that we can fetch the properties individually. We can just ask, hey, I want user Sarah's name. And when we print these, even though we have the same type, of course, these are different instances of that data type. So Sarah Middleton will print Sarah Middleton and Tyler will print Tyler Batillion. Okay. Okay. The next thing I'm showing you is, this is something that is, again, not available in every programming language. Like Java, for example, would not let you do this exactly unless you went out of your way to make name a special type of property. But in Python, you can always just add properties, change properties, just using this dot notation. So if I want to change my name to Frank Fredrickson, then I just say user Tyler.name equals Frank Fredrickson. And we can see over here, if I go to user Tyler, close this watch tab and call stack, we don't need that stuff. You can see that my name has been changed to Frank Fredrickson. It used to be Tyler Batillion, now it's Frank Fredrickson. You can just change properties at any time using the equals statement. Can, of course, print my name out again. Okay. And then finally, we can also, tends to be preferred, this behavior here on line 52 A lot of coders would consider this a bad idea. You're changing the property of an object, not using one of those object's methods. That's frowned upon a little bit. In Python, we kind of do it all the time. In certain more type-safe languages and certain more heavily object-oriented languages, especially something like Java or Rust, maybe, this would definitely be frowned upon. So keep that in mind. Different norms for different programming languages. The last thing I'll show you is the quote correct way to change the internal state of an object is to use one of its methods. So here we have Sarah Middleton. She's 32 years old. We just printed out her age, 32. When we call the birthday function, step inside, you can see I just have a print statement that says, hey, Sarah got older. Yay. And then we say self.age plus equals 1. That will take both this self object and this Sarah object because they're the same object. And it'll change this 32 and this 32 both to 33. And then we can see when I print Sarah's age, Sarah's 33. Okay. What do you think about this? Questions, comments, feelings, concerns? Cool. Then let's attempt this micro exercise. What I'm challenging you to do here is add another method to the user class. And I want this method to be something that changes the user's name. So you should accept two parameters, the self parameter, which you always have to accept, followed by the new name. And then write some code in that function that allows the user to change their name. When you call it, it would look something like this. User Tyler dot name change new name. That should change the user Tyler's name to new name if you've done this micro exercise correctly. Any questions about what I'm challenging you to do here? I'm going to put 4 minutes on the clock for this. I don't think it's too complicated, but this is also the first time you're creating a method. It might take longer. Let me know if you finish. All right. Beep, 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 beep. Does anyone have a solution to this micro exercise that they'd be willing to share with us? And don't all volunteer at once. That's very overwhelming for me. That's okay. I completed the micro exercise myself, so I didn't need you to do it, but it would have been cool, just saying. Okay. So I added this method on line 30 of the file. I just called it change name. So same as ever, you're defining a function, you give it a name. It takes two parameters in this case, one for the self object, which again, methods always take, that's just built into Python. And the other is the new name that will pass to that function when we call it. Okay, so if I debug this, and I'll put a breakpoint further down. So we jump down to here. You can see right now, if I open up user Tyler, the name is Frank Fredrickson because I changed it up here. I'm going to change the name back to Tyler Batillion, but this time I'm going to be Tyler Batillion the third. I've always wanted to be a third. I thought that'd be cool. It's a little Ender's Game joke for you, by the way. Okay. Now you can see the name's been changed, Tyler Batillion the third. And if I print out the result of generate report, I'm 58 years old and my email address is teb@tebslab.com. Boom. Okay. Not so bad, hopefully, so far. Questions about this overall concept before I add a little more complexity, before I show you an example that's a bit more realistic and a bit more complex as a result.
So I'm probably putting the cart before the horse here, but my initial instinct was to do what you did, and I just created a method called set name or something like that.
Sure.
But because of experience with other languages with getters and setters, I thought, oh, I'm gonna look it up real quick and see like what the convention is. And I noticed that you can also use something called a decorator when creating a getter or a setter method. Are you familiar with that?
A little bit. I don't use decorators very much myself, but you probably did it, right? So why don't you share your screen and show us what you did?
Yeah, I'll show you here. So you should be able to see the screen here. So mine looks like yours now, but since it's fresh on my mind, I can show you. So here's my, just zoom in for you. Get this out of the way. So set name, self name, blah, blah. And essentially with the decorator, it was just something like, if it was a getter, you would just say that it was property. And then
then
since
give
we're
it the
talking about
name.
name, we would just say name. And
Mhm.
then rather than use self.name, we would use an underscore, I guess maybe not to conflict with the method name.
Yeah,
And then,
there's two reasons for the underscore. So the first is, like you say, you don't want to create a conflict between name and name. A second is conventionally, when you do that little underbar in front of a property of a class, what you're saying is that that property should be a private property. It's not respected by the code, but it's a very common convention to mean the only way, what it means to be private if you're not coming from a heavily class-oriented language. It means the only way to change that property should be by one of the methods of that class. And in many programming languages that are heavily object-oriented, that's something that the interpreter can enforce, that the code itself won't let you do. You'll label that property as private, and then you can only change it from inside the method. But Python does not have a concept of private variables. So programmers who have come from other languages that have private variables use this convention to mean, hey, that's a private variable. You should only change it by using one of the methods that's on this class.
Okay, and so then would I need to go back into my Dunder init and make these
Yes, you would.
private as well?
Exactly.
Gotcha. Okay.
Yes, and then the decorator concept, decorators are actually pretty widely used in Python. Decorators are a way to change or augment the behavior of a particular function, and you can define custom decorators to do anything that you want. This property one does some stuff that I'm not deeply familiar with, but there are other decorators that say like memoize or cache the results of this function. Other cool stuff like that.
Yeah, and then I guess just the last thing here is that if you do property.setter, then you can have a method by the same name, but with an additional argument and differing functionality.
Right. Yes, and the augmentation of the method using a decorator in that case is critically important. If you just have two functions named name without decorating them, then the last one that you define will be the one that's always used. You don't have access to that other function anymore.
Ah, interesting.
So the decorator changes the behavior there.
Gotcha.
Cool. What else? Questions, thoughts before I show you a slightly more complicated example of a class? Cool. Then let's go to O3, an example. Okay. In this example, I'm trying to make it a slightly more realistic. This is a very, intro kind of session, so there's a limit to how realistic we can get, but also be able to display these three things. Composition, that is to say, using objects within objects. We're going to create two different objects here and use them in each other. Okay. Two is the concepts I've been talking about, state and behavior. These two classes have both state and behavior. And I think we have two examples of overriding the magic methods, which is very fun, feels very powerful. Operator overloading is pretty cool. It allows you to do things that are very convenient for your code. Okay. So the first class is called a newsletter account. This is meant to represent someone who runs a newsletter. And so if I ran multiple newsletters, I would have multiple newsletter accounts, one for my newsletter about puppies and the other for my newsletter about coding, the two things that I love most in this world. Newsletters have a title and they maintain an operator email. And when you make a new newsletter, your mailing list is empty. And I'm just using a plain old Python list for that. Okay, so I'm specifying a title and an operator email when we create this. And anytime you create a new newsletter account, it's empty. You can register a new subscriber. That just appends them to the subscriber list if they're not already in it. You can unsubscribe them if the subscriber is in that list, you just remove them from the list. Again, append and remove, if you're not familiar, are just methods on the list class. Okay, so these are just things that Python lists can always do. And then finally, I can publish my newsletter with some content. This is to mock out the idea of sending an email to each of those individual subscribers. You'll see this send email function is actually just defined right here, and it says pretend this sends emails because I didn't want to connect to an API and send emails and blah, 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 blah. So just pretend that someone had actually implemented this to actually send out the emails. That's totally possible to do in Python, but beyond the scope of this first time you're seeing classes, okay? And then finally, the last thing you can do with the newsletter account is I've overwritten this stir method, str. So now anytime we try to convert a newsletter object, a newsletter account object, to a string, this string will be the result. It'll say newsletter, the title of the newsletter, has the number of subscribers the newsletter has, subscribers, and is sent from the operator email. And this will allow us to, for example, create a newsletter account and then just print that variable. And when we try to print that variable behind the scenes, Python will turn it into a string for printing by using this method, okay? Or if you use the top level str on a newsletter account, if X was a newsletter object, then this str function would be called. So we're overriding some default behavior that Python has by using this str magic method. Let's pause here for questions about the newsletter account.
Hey Tyler, I just have a question.
Great.
So what's the point of line 30 with the I'm sorry, I forgot what that what's
Dunder.
yes. Yes. Well, yeah, what's the point of that if you're just returning a string?
So what it allows me to do is return a specific string anytime Python would have been told to cast this object to a string. And to demonstrate, let's comment out these 2 lines of code, and then I'll come down here and in main, I'll put a breakpoint right here. Without the magic method, what Python's default behavior is when I print, so I've just created a newsletter account, I've stored in this variable the lab report, and you can see the lab report has my operator email that I specified. It has the title of the lab report. It has no subscribers right now. And if I print, it prints me this. This is Python's default behavior for turning an object into a string. It tells me the type of this object is a newsletter account, and it's at hex this number. This is the location in RAM. This is like the actual address of RAM where that object lives. It's physical location inside of your computer. Kind of cool, to be honest, that it can tell you that. I love, just like peeks under the hood. But it's not very useful for you and I talking about what this object is. So if I go back and uncomment these lines of code and restart, now what you'll see when I print is I no longer get that default behavior, but instead I get this behavior that I specified. Hey, that thing is a newsletter called the lab report. The lab report has 0 subscribers and is sent from Teb at tebslab.com. Do you feel like that answers your question, Victor, or do you want to follow up?
Yeah, it does. Thanks.
Cool. Heck yeah. Okay, great. So I'll create one other newsletter. I told you I loved coding and puppies. The lab report is about coding, and pup dates is about what's new with dogs, sent from bingo at welovedogs.com. That's a Bluey reference for all of you who have children. Okay. And if we print that, it prints newsletter, pup dates, what's new with dogs, has 0 subscribers and is sent from blah, 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 blah. Okay. So we've created 2 newsletters. We're about to create the second type of object that I've created here, the newsletter subscriber object. So let's take a look at it. It's got 3 methods, all of which are magic methods or dunder methods, okay? We initialize a newsletter subscriber. Newsletter subscribers just have names and email addresses. We're not collecting a lot of data on them because we're not evil big corp yet. We probably should to feed our machine learning models and all that, but we'll learn that later, you know. So just two properties for the newsletter subscriber, name and email address. And then I'm overriding this method, the EQ method, and the str method. Let's do the str method first because we've already seen what that does. I'm just once again changing the printing behavior basically for what happens when I need this thing to be cast as a string. I'm going to say, hey, that's a newsletter subscriber, and I'm going to print their name and email address. Okay. Now, EQ, this magic method overwrites the behavior of the double equals sign. Okay, so when we ask like 1 equals 2 and it returns false to us, that's because behind the scenes, the integer class has a dunder EQ method. And that method is called when we compare two integers. Because I'm overriding the dunder EQ method here in my newsletter subscribers, whenever I compare a newsletter subscriber to anything, and so the way this works is whatever's on the left-hand side of the double equals, that's what controls which double under equal method is called. So when I call a newsletter subscriber on the left is equal to, double equal to, anything else, this method gets called, okay? And all I'm doing is checking if the other thing, right? So if I said x double equals y, then x is self when this method gets called, and y is other when this method gets called, okay? So if the other thing is also a newsletter subscriber and me and the other thing have the same dot email address property, I'm saying this is true, okay? So no matter what my name is, if I share the same email address with someone else, my model believes those are the same person. You're identified by your email address. That's an assumption that I'm encoding. A person is uniquely identified by their email address in my data model. That is true because of the way I've written this code, okay? Otherwise, I'll return false. So if I compare a newsletter subscriber to an integer, it'll say those aren't the same, false. Okay, questions about this EQ method? Then let me show you the whole purpose of implementing that EQ method. I've already shown you. If you're really paying attention, you might have noticed, but it's easy to miss, okay? So here we are. We're about to create 4 newsletter subscribers: Buzz Aldrin, Sarah Connor, Sharif Sakar, and Sakura Nakamoto. Okay. We can step into one of those. We'll look at Sarah Connor. She defeated the Terminators. Good for her. Well, just kidding. Her son, John, obviously. Not that interesting. We created Sarah Connor. Now Sarah has a name and an email address, Robot Hater 55. I'm so clever. Oh gosh. Okay. Sharif and Sakura both exist as well. To demonstrate the printing function, the str function, we can step in here. When I say print Sharif, it goes to the str function and says, oh, Sharif's a newsletter subscriber. Sharif's name is Sharif Sakar, ssakar@fakeemail.com. Okay. I can register Buzz and Sarah for my lab report. And if I do that, we can step into that function. You can see first I check, is that subscriber already in my mailing list? My mailing list is currently empty, so nothing interesting happens there. I append Buzz to my mailing list. So now Buzz is a member of the lab report. We can see, it's harder to see in that one. We'll open it over here. Lab report, mailing list. The thing at position 0 is Buzz. Moonboy 1969, which is probably the date he landed on the moon, right? Okay. Cool. And then if I print the lab report, now you can see since the properties have changed, I say, oh, that's a newsletter. It has 2 subscribers now. Okay, kind of neat. Similarly, we can add Sharif and Sakura to the pup date report. And now the pup date report, what's new with dogs, has 2 subscribers. But check this out. I've already registered Buzz. So Buzz shouldn't sign up for my newsletter twice. It would be bad form for me to send that email to the same email address 2 times in a row. When I step in here, what we'll see is when I ask this question, if not subscriber in self.mailing list, a lot happens behind the scenes here that you might not know if you're not paying attention. It's going to loop over every person in the mailing list, and it is going to ask, is subscriber, this object, double equals to each of the objects in that mailing list? That is the behavior of this in operator. So I'm going to put a breakpoint on my newsletter subscribers double EQ method. I'm going to put a breakpoint right here. And then I'm going to click this play button. And voila, we're on this line of code. It's asking right now, hey, is Buzz Aldrin the same as Buzz Aldrin? And because they share the same email, these are both newsletter subscribers and they share the same email address, even though they have a different name, by the way, Buzz and his real name, Edwin Eugene Aldrin Jr., much less fun than Buzz. These are considered the same person, and therefore what's happening here is second version of Buzz didn't get added to my newsletter, okay? Because of it, well, we jumped ahead a little bit. Because that was the actual plain old double equals. But you can also see that it didn't re-register Buzz because I'll open up the lab report and we'll still only have those two homies, regular Buzz Aldrin and Sarah Connor. So this double EQ method is being called behind the scenes, both when we're doing something like this. Whoops, not there, right here. If not in, that utilizes the equality operator behind the scenes. And then it happened directly on this line of code where we created a second Buzz Aldrin, but left him the same email address and compared them directly. This printed true, even though there are two instances of the object, because we redefined the equality operator. It told us that these were true. Okay. A lot just happened, so let's pause. How do you feel about this?
It's probably out of scope, but anytime I see something like you mentioned where we say, is some object not in some list of objects? And you said this is checking every single one. So right now it's pretty trivial. We only have two objects in there. But what happens when you have an enormous list and every time we add a new subscriber? Are there ways of optimizing that?
I'm sure there are. We could use a dictionary, for example, to host this information and just do a point-to-point lookup rather than looping through.
Ah, okay. So in that case, you would just say, hey, check and see if this email exists as a key property. And if it doesn't, then go ahead and add it to this dictionary.
Yeah, exactly.
Nice.
Or could use a different data type, like a set would be okay for this as well. What else? One more cute thing. This is operator. You may not have seen it before. This is operator, even though Buzz is double equal to Buzz alternate, because they share the same email address, because we overwrote the equality statement. This is operator is still going to tell us these two are not the same. It's going to say false. Let's prove that's true. There's the false. Because the is operator asks the question, are these two things at the same memory address? Are they literally living physically in the same location? And if they are, if you have two variables that point to the same memory address, which is really easy to do, then this will say true, okay? So this is a way to know if two variables point to exactly the same thing. This is a way to know if two variables share the same value according to whatever the behind the scenes rules for comparing those things are. We redefined it in this case using that double underscore EQ. For numbers, right, it's whether or not it's the same number. 1 is equal to 1. Okay. And every data type defines their own equality method. Sometimes they're the same. Sometimes the behavior of double equals and is turns out to be functionally the same, and sometimes it does not, as in this case. Okay. If we register sign up again here, we'll see that we once again triggered our double underbar EQ method. And if we look at the call stack, you can see we called main. From main, we called register sign up. In the register sign up, we asked that question if not subscriber in self.mailing list. And you can see that resulted in our equality function being called. Okay, this call stack, by the way, can be very useful for tracking down the order that your code, the order that methods were called in, tracking down what called what from where, and tracking back your errors if you're not familiar with it already. Okay. So I'll step out of this function, We won't have registered Buzz alternate to sign up for the lab report because Buzz regular was already in there with their email address. We can prove that's true if we want to. Mailing list still just got 2 people in it. Okay. And then finally, we can publish the lab report, which just loops over all the subscribers and calls this send email function that says, welcome to the lab report, was sent to moonboy1969 at fakeemail.com. Okay. Just gonna hit play. We can see all of the, oh, get out of here. Can see all of those happening for both of the publish calls that I made. I said, publish the lab report, publish the pup date. That resulted in all of this. And then finally, I directly appended, oh, I was supposed to make you do this as a micro exercise, but I already filled it out. That's a problem with my resources. Okay. This is an example of something, again, that you're not supposed to do. I just said lab report.mailing list. I directly accessed the mailing list and appended Buzz alt to it, which changed my behavior because then I was able to add Buzz in there twice. If we put a breakpoint on this line and rerun this code and play it, even though I shouldn't have been allowed to based on the code I wrote above, I've put fake, second Buzz and first Buzz in the same mailing list. Even though they share an email address, I shouldn't have been able to do that. I did. RIP. Okay. And then if you had the micro exercise would be like, whoa, consider why the subsequent lines of code would be wrong in this case. Now, when I unsubscribe Buzz alt, I won't actually be getting rid of both Buzzes. I've got 2 Buzzes in there now. This unsubscribe function, the way it's written, it only removes the first instance of the subscriber who matches. So I'll remove Buzz original from the lab report. Sarah Connor's now the first person. And the second Buzz that got added is still in there, even though I asked it to specifically unsubscribe Buzz alt, the second Buzz, Eugene Edwin, not Buzz. Okay. So this is an example of behavior where you didn't respect the privacy of the variable, and that causes problems. This is something that Python just kind of struggles with. And one of the solutions is like what you saw Ian do with the property getter setter and the underbar. And the other is just be diligent, use methods, etc. Okay. So questions, comments, feelings, concerns, needs, desires. Then the only thing I have left to show you is an exercise, 2 exercises really, that can both help you practice your use of classes in Python. You can view these either here in Visual Studio Code, or you can look at them on the GitHub. They look a little better on GitHub, honestly, the markdown files. You can see what I'm challenging you to do in this calculator is to make a 4-function calculator. I describe all these stipulations, but I think it's easier to see what I'm challenging you to do is what's in this solution file here. So don't look at that code. That code is dead to you. But let me show you what happens when I run it. I have like an old school calculator here. So I can type some number 4, and that becomes the current number. And then I can say plus, and then I can say 5, and it writes a 9. And then I can say plus, and then I can say 3, or minus 5, or times 9, and it'll keep a running total. There are a couple other functions, like I think I have C, oh yeah, I detect invalid input, give you this nice, cute little error message. Error, C was invalid input. Lowercase c clears the output. What's the other thing I allowed it to do? E. Oh, E is for exit. And that exits the calculator display. Okay. I'm challenging you to do this all in the context of a class. So make a class that's the calculator. The calculator class will control the printing, control the state, which is the current number that you're displaying on the screen, and a bunch of other things. Okay. Here's a couple tips. Nice, cute. I think this is a very useful exercise. Cute and challenging if you've never used classes before. And then if you want to do even more, I have made a very stupid video game for you to extend called Dungeon Mon. And it's super open-ended. Basically, there's any number of things you can do to change the game. But if you go back to your code and run this 5e Dungeon Mon code, which is a starting point, basically, you can check out the hero class, the Dungeon Mon class, and the main loop, which controls all of the logic, all of the game logic, basically. Well, not all the game logic. It controls the interaction, and much of the game logic is contained inside of the classes themselves. Then, super boring. You just hit enter. Your Dungeon Mon hero fights a Dungeon Mon over and over again. It spawns random Dungeon Mons. And if you hit enter, you can fight the next round. You can see I've been killing slowly Dungeon Mons. Okay, let's actually make this a little bigger. You can see the entire output. My hero's losing life, 20 out of 40, 16 out of 40. I'm about to kill the Dungeon Mon. Oh, I vanquished a Dungeon Mon. Okay, but it's boring. There's a bunch of stuff in that write-up that says, here are some features that I reasonably think you could add to this class, or to these two classes, and make the game a little more interesting, more fun, either visually appealing or by adding randomness or whatever you want to do. Okay, so those are two things that you can do to practice. I imagine you might not want to practice right now, and if that's the case, then you can just do this later. If you want to practice right now, I've got a few minutes to stick around and give you some guidance, help you as you work through those. But let me pause for questions and comments, and then I'll say two more things, and then either get to work and I'll sit here and be your little office hours buddy, or you'll both leave and that'll be fine too. And you can email me with questions you have about the solution. So what do you think? Sweet. Then here are the two things. The easiest way to say thank you to me for providing you with this free course is to sign up for my newsletter. You can just click that link, blog.tebslab.com. There will be a little white box that appears on the screen. You can type your email in there. Then you will hear from me. You'll hear from me once a month. It's not going to be an overburden on your email. You hear from me once a month. I'll market my classes to you at the top. I have some classes for sale. I also do corporate training. And then I'll write a long article about some technology thing that's happening. Last month, I wrote about C2PA, a really interesting emerging standard for provenance authentication that's going to supposedly, we'll see, help us understand where our media are coming from. So like the New York Times can use C2PA to say, I validate that this is something that I did in fact publish. OpenAI and Gemini have started incorporating C2PA credentials into the images they generate. That's what I wrote about last month, okay? And then finally, if you want to spend money on classes that I teach, you can click on that link and sign up for a class. I have one that's very cheap coming up, just about not programming, but how to use generative AI, what's happening behind the scenes conceptually, how do these things train, and then when do they fail, some prominent examples and why those examples failed, followed by finally some tips and tricks for using some of the current models like ChatGPT and Gemini and Stable Diffusion, stuff like that. And then another more expensive class, a full-on introduction to machine learning, very much in the weeds. How do these models work? Let's build some, blah, 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 blah. Cool. So those are two things you could do. It's my only marketing pitch. Don't worry, I'm all done marketing to you. As always, questions, thoughts, comments, concerns, feelings, needs. Are either of you going to do the exercise right now?
I am not going to have time to do it right now, but I do plan to do it.
Cool. Feel free to email me. My email address is on my website, but I'll type it as well.
Cool.
Any questions you have about that? There is a solution provided to the calculator exercise, as you saw. There's no solution provided to the Dungeonmon episode exercise just because it's so open-ended, but I'd be happy to talk to you about it.
Okay.
Cool.
Well, I
Cheers.
appreciate all the time you took. It was decently informative for me, so I appreciate that.
Great. Decently informative. I'll take it.
Yeah, because I haven't, like I said, used Python classes before. I've seen them in other languages, but not specifically Python.
Cool. Yeah, and the only thing that will have been like really special and unique to Python is probably the lack of privateness and also the dunder methods, which are pretty cool. Operator overloading rules.
Yeah, that was neat to see the dunder equals be overwritten, and same with the dunder string. Because I wasn't aware you could do that.
Oh yeah, and you can do it for tons of stuff. Like you can overload the bracket notation operator, you can overload plus and minus, blah 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 blah. You can make really, really nice to use classes in Python using all that stuff.
That's awesome. But yeah, so thank you, because like I said, this is informative enough that I think it's time well spent. For me
Great.
especially.
Shares my pleasure. Victor, is there anything I can do for you? Are you going to attempt the exercise right now?
Hey Tyler, I just have a general question about
Great.
Python. Can you just go more into depth about like the use cases for Python and why Python over some other languages?
Sure. So probably honestly, the biggest reason to use Python over some other languages is momentum, more or less. Tons of things are already built in Python, which means there's a big community of people who are using Python, which means there's lots of libraries to do lots of stuff that's written in Python. In particular, I found the machine learning community has kind of coalesced around Python as their main tool for entry. Um, to be honest, to me, that is the best reason to use Python, the programming language. Not anything specific about what Python is good at, but what the community has decided Python will be used for. Similarly, like if you're writing web apps, you got to use JavaScript because JavaScript's what runs in the browser. I mean, I know we have WebAssembly now, but in reality, if you're using Vue.js, you got to write JavaScript. Okay. So the community kind of decides in a lot of ways based on momentum what's useful. But I will say some things that I think Python does better than most other programming languages is scripting type workloads. I love writing scripts in Python. If I've just got like, I've got a command line tool that I want to implement that does a few simple things, queries an API, writes a report for me, transforms some data, stores it in a new data format, slurps up an invoice from a customer that always comes in a certain format, stores it into my database format, like ETL type stuff. Python is great for that. Python is not bad. It's pretty good, as good as any other language, really, for doing like web server development. There's some good frameworks like Pyramid and Django for building web servers. You can do similar stuff with Node.js frameworks or Java frameworks. One of the things that I think Python has on top of either of those two, Java or JavaScript, it strikes a better middle ground between kind of Java's really heavy-handed type safety, object-oriented, you must build everything as a class or an object in Java. And JavaScript is like a little more, it's too permissive. You're allowed to do anything in JavaScript, and it won't tell you that you've made a mistake for, 10 minutes, like the server's running and you've got something in a bad state, something's undefined that shouldn't be, or you tried to add a number and a string together and it was like, oh, sure, I just turned that string into a number. I didn't tell you that I was going to do that, but I did it for you. Aren't you happy? And you're like, no, I didn't want you to add the string Tyler to the number 2. Those are different. You should have told me. But JavaScript will just do it and give you not a number. And then you try to print something on an invoice and it's like, eh. So Python kind of strikes a better ground there. It doesn't mix types as much as JavaScript does, but it's easier to write. It's permissive enough that the language itself isn't getting in your way in a way that Java does. It's really bad for systems level engineering, Python. All three of the language that I mentioned so far are bad for that. You should pick up Rust at this point if you want to do like low level systems coding. Skip C. Rust is new and it's the king, and C is not memory safe and Rust is. Boom. That's security right there, baby. Does that kind of hit at at what you're looking for in your question, what Python's good at and why you'd use it?
Yeah, that was a great answer. I mean, I consider myself a noob in the space, so just any
Cool.
information I could get is just awesome.
Cool. Yeah, and I would especially, have you used something like, I don't know, are you interested in doing data analysis, machine learning type workloads at all in your future, or is that not the type of stuff you're interested in?
Yeah, there's definitely an interest there. I haven't dabbled into it much, but yeah, I would say the interest is there.
Cool. Then I would suggest looking at two technologies. One is a Python library called Pandas, and it's just a great way to work with tabular data. You can think of it as like a really powerful spreadsheet that lives inside your Python code and that you can manipulate with Python code. And then thing two is a product called Jupyter. It's a whole host of things, but what you'll find if you start looking into those communities, like the data analytics community, data science community, is they use this tool, Jupyter Notebook, for writing Python code, but that is meant to have like a visual output. For example, charts. You want to write some Python code that generates a couple charts about your data. Jupyter Notebooks are a really good way to write code. And it's an alternative, or at least that kind of code, I should say. And it's an alternative to Visual Studio Code or other IDEs.
Awesome. Thanks for that.
Yeah, you're welcome. Anything else I can help you with?
I think as of now, that's pretty much it.
Sick. Cool.
I appreciate you taking the time to answer my questions, and I enjoyed this class, and I plan on doing this calculator exercise.
Great. It's a good
tomorrow.
one.
Yeah, so looking forward to getting started on that.
Cool. Heck yeah. And if you get stuck or you have questions, feel free to email me. My email's in the chat. Otherwise, I will see you around or not. Thanks for stopping by, Victor.
Awesome, man. Thank you so much. All right. Good night, guys.
Toodles.
Have a good night.